Hello students, in this video we are going to discuss some of the important questions and answers of second PUC Chemistry chapter Solutions. In this chapter there are two formulas in the beginning, molarity and molality, to find out the concentration of solution. Molarity capital M is equal to WB into 1000 divided by MB into V, and molality small m is equal to WB into 1000 divided by MB into WA. Here W is mass, W represents mass, and M represents molar mass, and A represents solvent, B represents solute. The component taken in large quantity is called as solvent, and the component taken in small quantity is called as solute. So WA is the mass of solvent and MB is the molar mass of solvent. Similarly, WB is the mass of solute and MB is the molar mass of solute. So among molarity and molality, molality is independent of temperature. One more important method to find out the concentration of tracer element. If the solute present in tracer quantity, especially pollutants, it can be determined by parts per million, and parts per million can be calculated number of parts of compound divided by total number of parts of all the components in the solution into 10 to the power of 6. One of the important law is Henry's law. It states that partial pressure of the gas in the vapor phase is directly proportional to mole fraction. Mole fraction symbol is X. Partial pressure of the gas in the vapor phase is directly proportional to mole fraction of the gas in the solution, X. And here proportionality symbol can be given as Henry's law constant KH. Henry's law constant has important significances. KH, Henry's law constant, is inversely proportional to solubility of a solute or a gas in the solvent. So relationship between KH and solubility is inversely proportional. Means if the KH value of any particular gas is more, its solubility is less. If KH value of any particular gas is less, its solubility will be more. Now, importance, Henry's law application is very important. Henry's law applications, they are used in the preparation of soft drinks. It is used by scuba divers to prevent from Bend's disorder, Bend's condition. It is used by mountain climbers to protect from anoxia condition. One more important law in this chapter is Raoult's law, and this law states that in a solution of volatile liquids, partial pressure of each component in the solution is directly proportional to the mole fraction of the component in the solution. Partial pressure of each component, whether it is 1 means solvent or partial pressure of solute 2. So for solvent we can give the symbol A or 1. For solute we can give the symbol B or 2. So partial pressure of each component in a volatile liquids directly proportional to its mole fraction. P1 is directly proportional to X1 and P2 is directly proportional to X2. So P total is equal to P1 naught. P1 naught is the partial pressure of component 1 in the pure state into X1. X1 is the mole fraction of component 1 plus P2 naught. P2 naught is the partial pressure of component 2 in pure state into X2. X2 is the mole fraction of component 2. Difference between ideal and non-ideal solutions are very important for the exam. Ideal solution obeys Raoult's law. They have delta H mix and delta V mix is equal to 0, and the force of attraction between solvent and solute is equal to solvent and solute. And non-ideal solution does not obey Raoult's law. Delta H mix and delta V mix both are not equals to 0, and the force of attraction between solvent and solute is either greater or lesser than that of AA and BB. This chapter has one more differences, that is non-ideal solution showing positive deviation from Raoult's law and non-ideal solution showing negative deviation from Raoult's law. In case of positive deviation from Raoult's law, the force of attraction between solvent and solute is lesser than that of solvent and solute, and delta H mix and delta V mix both are positive. In negative deviation from Raoult's law, the force of attraction between solvent and solute is greater than that of solvent-solvent and solute-solute. Delta H mix and delta V mix both are equals to negative. Azeotropes or azeotropic mixture also very important. Azeotropes are the binary liquid mixtures having same composition in liquid and in vapor phase, and they boils at constant temperature. So example, 95% ethyl alcohol and 5% water, they forms minimum boiling azeotropes. 68% nitric acid and 32% water forms maximum boiling azeotropes. One more very important part of this chapter are colligative properties. There are 4 colligative properties, and the value of these properties depends on the number of the particles present in the solution, but not on the nature. So first colligative property is relative lowering of vapor pressure. From any one of the colligative property, numericals are very important to the exam. So first we are going to see the numericals related to relative lowering of vapor pressure. Means when you add a non-volatile solute into the volatile solvent, the vapor pressure of that solution is going to decrease, becomes lower. So 5.8 grams of non-volatile solute. So they have given mass of solute 5.8 gram dissolved in 100 grams of carbon disulfide. Means here carbon disulfide is solvent, Wa. So whichever has taken in larger quantity is solvent, mass of solvent. Smaller quantity is mass of solute. So then they says the vapor pressure of solution was found to be vapor pressure of solution, means PA. PA is the vapor pressure of solution. It is 190 mm of Hg. Calculate the molar mass of solute. We need to find out the molar mass of solute Mb given vapor pressure of pure carbon disulfide. Vapor pressure of pure carbon disulfide is given as Pa0. It is 195 mm of Hg. And they have given molar mass of carbon disulfide, that is 76 grams per mole. So you can see clearly according to the question, when we add 5.8 grams of non-volatile solute in 100 grams of carbon disulfide, its vapor pressure has been decreased from 195 to 190 mmHg. In those conditions, we need to find out the molar mass of solute. So we have a formula to find out the molar mass of solute. Mb is equal to Pa0, vapor pressure of pure solvent, into Wb, mass of solute, into Ma, molar mass of solvent, Wa, mass of solvent, into Pa0 minus Pa. Pa0 is vapor pressure of pure carbon disulfide, and Pa is the vapor pressure of solution after adding 5.8 grams of solute. So after substituting the given values, you calculate, you will get the correct answer, and molar mass unit should be grams per moles. Grams per mole is a unit. Second colligative property we have is elevation in boiling point or ebullioscopy. Whenever we add a non-volatile solute into the volatile solvent, the boiling point is going to increase, and that can be calculated with the delta Tb. Delta Tb is equal to Tb minus Tb0, where Tb is the boiling point of solution and Tb0 is the boiling point of pure solvent. And how much temperature has been, how much boiling point has been increased, delta Tb is directly proportional to molality. Small m is molality, and proportionality symbol can be given as Kb. Kb is ebullioscopy constant or molar elevation constant, whose unit is Kelvin kg per mole. Kb is ebullioscopy constant, its units is Kelvin kg per mole. So from this also numericals are very important. Let us see, we have a numerical. The boiling point of solution, the boiling point of solution of 0.1050 grams of substance in 15.84 grams of ether. So here two masses has been given. Gram is a unit of mass. The lesser mass is the mass of solute Wb, and larger mass is the mass of solvent Wa. So it is said that the boiling point has been raised to 0.1 degree Celsius. So delta Tb directly has been given. Delta Tb is 0.1 degree Celsius higher than that of pure ether. After adding 0.105 grams of non-volatile solute to 15.8 grams of ether, the boiling point raised by 0.1 degree Celsius than the boiling point of pure ether. We need to find out the molar mass of solute Mb. Kb value given 2.02 Kelvin kg per mole. So we have a formula to find out the molar mass by elevation in boiling point. Molar mass Mb is equal to Kb, ebullioscopy constant Kb, into Wb, mass of solute, into 1000 divided by delta TB. Delta TB is elevation in boiling point into WA. WA is a mass of solvent. So when we substitute KB value, WB into 1000 divided by delta TB and mass of solvent 15.64, you calculate, you will get the answer in grams per mole. Now, third colligative property is depression in freezing point or cryoscopy. It means whenever you add a non-volatile solute into the solvent, the freezing point is going to decrease. We know the freezing point of water is 0 degrees Celsius. When you add a non-volatile solute like glucose or salt into it, the freezing point goes below 0 degree. It means it will go in a negative. So, how much temperature has been decreased? It is calculated by delta TF is equal to TF naught minus TF. TF naught is the freezing point of pure solvent and TF is the freezing point of solution. So delta TF, how much freezing point has been depressed, is directly proportional to small m, that is molality. And proportionality symbol is given by Kf constant. Kf is cryoscopic constant or molar depression constant. Unit is Kelvin kg per mole. So numericals related to this are important. So we have a numerical 12.6 grams of non-volatile non-electrolyte dissolved in 75 grams of water. So 12.6 is the mass of solute and 75 grams is the mass of solvent. The freezing point of this solution is 271.9. So freezing point of water we know 0 degree or 273.15 Kelvin. It is a freezing point of pure solvent, pure water, TF naught. So after dissolving 12.6 grams of a non-electrolyte, the freezing point has been reduced from 273 to 271.9. So molar depression constant Kf is given 1.66 Kelvin kg per mole. We need to calculate the molar mass of solute. Freezing point of pure water has been given. So we have a formula to find out molar mass by using cryoscopy or depression in freezing point. Molar mass is equal to Kf cryoscopic constant into Wb mass of solute into 1000 divided by delta Tf depression in freezing point into Wa mass of solvent. So substitute the values and calculate, you will get the answer in grams per mole. Now the fourth and last colligative property is osmotic pressure pi. So from this also we have a numericals. 200 centimeter cube of aqueous solution of protein. So 200 centimeter cube is the volume of solution, and that 200 centimeter cube we need to convert into liters. 200 centimeter cube is equal to 0.2 liters. 0.2 liters. So protein contains 1.26 grams of protein. So 1.26 is the mass of protein, that is mass of solute Wb. The osmotic pressure of such solution at 3. So temperature is 300 Kelvin. And we have to calculate the osmotic pressure was found to be 2.57 into 10 to the power of minus 3 bar. We have to calculate the molar mass of the protein Mb. So the relationship between osmotic pressure and molar mass of solute is Mb is equal to mass of solute, R is universal gas constant, T is temperature, pi is osmotic pressure and V is volume. So the mass of protein is 1.6 grams, R value is given 0.0821 liter atmosphere per Kelvin, T is temperature, that is 300 Kelvin, pi value 2.57 into 10 to the power of minus 3 and volume V is 0.2 liters. When you calculate, you will get the molar mass of protein 60.36 into 10 to the power of 3 grams per mole. Now the last topic of this chapter is reverse osmosis. Reverse osmosis means, so when you take a tank separated by one semi-permeable membrane. So in reverse osmosis, the semi-permeable membrane is used cellulose acetate. So at one side of the tank you take the salt solution, salt water or sea water. Say for example this is sea water, and at one side you take pure water or normal water. So sea water is a concentrated solution and water is a dilute solution. On concentrated solution, when you apply pressure, and that pressure should be greater than pi, osmotic pressure. So at that time the water molecules start moving from concentrated solution to dilute solution, means osmosis will takes place in reverse direction. That is reverse osmosis. So when pressure more than osmotic pressure applied on concentrated solution, solvent molecules, means water molecules, start moving from concentrated solution to dilute solution through semi-permeable membrane. So in reverse osmosis, in RO, the semi-permeable membrane used is cellulose acetate, and RO, reverse osmosis, is used in desalination of seawater. So last topic is Van 't Hoff factor I, small I. Van 't Hoff factor I is equal to normal molar mass divided by abnormal molar mass. Okay, when solute undergo dissociation, Van 't Hoff factor I is greater than 1. For example, you take solute NaCl. When you dissolve it, it will dissociate to form Na plus and Cl minus. So its I value is greater than 1. Similarly, when you take solute like acetic acid undergo association, so its Van 't Hoff factor value is lesser than 1. So when I value is equal to 1, exactly equal to 1, it means that solute does not undergo dissociation or nor undergo association. Thank you.